Okay, well, we're at about 9:15. 2, 4, 6, 8, 10, 11. So we're a few short of everybody being here, but we'll go ahead and get started. I went ahead and started the Zoom meeting. We'll use that to record what we're talking about today. And that'll let you, when I get ready to do some stuff with Code Composer Studio, it'll be able to let you look at my screen a little bit more easily if you want to. Yesterday, as we ran towards the end, we're getting to these slides on STR2K. And I wanted to just make sure, I felt like I didn't really give this much of a talking to Monday, since we're running towards the end. I want to talk to you about this because this, first of all, this is a classic function in standard C. But more importantly, there is a way to make this. This is a non-reentrant function, but there is a way to make this function reentrant. And I'd like to talk to you about that so that you can kind of understand when you're trying to make sure that your functions are reentrant, you can see at least one technique that you can use to do that. So let's talk first of all about what this function does. What this function does is that it takes a string. So there's a sample string, and you give it a list of delimiting tokens. And basically what it does is it divides that string up into pieces, and one at a time will give you the elements of that string that are separated by the pieces. So in this case, space, comma, period, and dash are our tokens. So the idea is that when we run this through STR2K, or STR2K, it's hard for me to pronounce that properly. It's STR2K, because it's getting a token. What it's going to do is it's going to run through this string. Well, a dash is a token, a space is a token. It's going to give you the word this, which stops that token. There's a space. It's going to give you the word a, and then there's another token. Then it's going to give you sample. Then it's going to give you string without the period. And the way this thing works is that the first time you call STR2K, you pass it both the characters that you want to use as delimiters and the string that you want to parse up. And it returns a pointer to the first item in there. And basically what it's going to do in this string is going to return you a pointer to that key, and it's also going to find that next delimiter, and it's going to change it to a null character. So now, whatever is pointing to that T is pointing to a string that terminates where that comma used to be, and it's now a null. And so then the next time you call it with the parameter that would normally point to the string that you're parsing. You pass it a null for that, and it knows that, oh, you want me to keep working on this last string. So that's what it does. So this is how it works. This is actual GNU public license software. Actually, the stuff that you can get that's publicly available doesn't have comments. All the comments are mine. Basically, this guy right here, this static char last S, or last string, that guy is why this is non-reentrant. Because here's what's going to happen. The first thing that it does is that it looks to see if the parameter that you're passing, that should be the string that you're pointing to, if that is a null character. If it is, then it's going to assign that value to whatever it is that we stored there. In effect, what we're doing is that we're saying, you didn't give me one, I'll use the last one that I had, which is not pointing where it was originally. It's pointing to the next character, as you can see down here. So we go in here into this do statement, and basically, if you found the end of the string, you're done. If you haven't found the end of the string, then this strchr dilim char, that is going to go find in here, are there any occurrences of this string in that, of these characters in that string? So when you find something, then because we had this plus plus, you're pointing to the character after the one that you just found, so you back that up one. And we say, okay, that's where we want to get started again the next time that we start. And if we haven't hit a null, we're basically returning what we pointed to, which would, in this case, would be the last S, and we're off to the races. Well, that's all great, but the problem is that now if I have two functions in a real-time operating system that are both using str to k, if I get one to pause while another one executes, now last S, because it stays with the function as a static, is going to be pointing to a different string than what we thought it was when the other task resumes. So what we can do to make this better is that we can add a pointer to character. Everybody know how to read that? That's a pointer to character. So now what we can do is that instead of carrying last S, we can have the individual function that's calling this str to k better keep track of that. And so now nobody can stomp on it. It's not in a global space. And so the only things that change here is that every place where we refer to last S, we're now doing a pointer to. Here, this down here gets a little confusing because we're looking at the character that the pointer that we're pointing to is pointing to. I think I said that in English. I think that's right. So that's what that is. We went over all that stuff. We went through this. So before we go on to a little bit of trying to understand a little bit about task switching, are there any questions from last week that you guys have? Anything, or from the homework? I'll go over the homework here after this, but is there anything specific that you guys want to make sure that we get to? So there was, on the discussion board, there's a question about map underscore functions. Who asked that question? Since that person's not here, we'll put that off. Okay, so we are going to do a little improvisational skit where we are going to be the operating system. And so what I need is that I need 5 volunteers. Okay, come on up. If you're a volunteer, come on up. All right, got 5 of you? Yep. Okay, cool. Now let's go over to that board. Let's erase 2 spots on that board. One on this side. Yeah, this. Yeah, we need a couple of spaces on the board. A little bit bigger than that. We just take that spot right there. Yeah. Okay, so this is our friend SysKit. Okay. Okay. And over here, this is for the kernel. Okay, and we've got priority 2. We've got task 2. At priority 1, we have task 1. And at priority 0, we have idle. Okay. Now, I need a volunteer to be sys-tick. Excellent. So the requirement is that you be able to count. Okay? I need a volunteer to be the kernel. Okay, you're the kernel. You're over there. Your requirement is that you can determine the difference between 2, 1, and 0. Got it? Okay. I need someone who wants to be those. Tap my indicator lamps. Okay. Who wants to be task 1? She is first. She gets to be task 1. You get to be task 2. And you're the idle task. Okay. So you guys all stand up here together. All right. So here's how this is going to work. Sys-tick. You are in charge of that side of the whiteboard. You're actually going to be writing on the whiteboard. Okay? Every 10 seconds or so, you figure out how often it is. What you're going to do is that you are going to go and take away from whoever has this thing that says running. Because every 10 seconds or so, you're going to get a timer interrupt. You're going to go grab the running token, take it away from whoever has it. Then you're going to come back over here and you're going to take your current time and you're going to increment it. Okay? When you are done incrementing it, you're going to give it to your good friend over here, the current. Yeah, just increment by 1. Okay? Now, so by like 10 seconds, I grab it. Yeah. Now, the other thing that you have to do is that you see you have this current time information for task 1 and task 2 with alarms. Okay? Task 1 and task 2 are eventually going to ask you to set some alarms. If when you change the current time, if you say, I'm going to change the current time, and it changes to whatever that alarm value is, then when you hand the kernel this running, you also tell him that task X is ready to execute. Okay? Okay, now, one of the tasks, task 1 or task 2, idle task doesn't get it. Task 1 and task 2, at some point in time, they are going to ask you to wake them up at a certain number of seconds from now. And so you're going to take whatever the current time is, add that in, and do your thing. They'll be holding on to the running when they do that. You can ignore them if they're not running. Okay? All right. Now, basically, you're going to listen to what the kernel says, or what the timer says, Mr. Kernel. And when you have the running flag, what you're going to do is that you're going to hand running to whichever task, task 1, task 2, or idle. Task 1, task 2, idle, right? Okay. You're going to hand to whoever is the highest priority that is ready to go the running flag. Okay? All right. Task 1. Your job is that when you get running flag, if your headlamp is on, turn it on. If it's off, turn it off. Okay? And when the battery breaks down. Uh-oh. Okay, so instead of, what I want you to do is I want you to either hold it up or hold it down. Okay? All right, so what you're going to do is that you're going to wait for however many seconds it says. You're going to tell timer to tell you to wait for that number of seconds, and you're going to hand back, once you've told them that you need to wait, you're going to hand your running flag back to the colonel. Okay? So you'll say, wait me in 2 seconds, and then give the running flag to the colonel. Okay? Task 2. You do the same thing, except you say, wait me in 3 ticks. Okay? Idle task. Whenever the colonel hands you the running, okay, your job is to sing or hum the angry word. And what so that happened the first time that I saw this, or that I did this. You don't know any of the Aggie Moore hymn? I've worked this. Yes, you hear the melody. Okay, everybody, let's hum a little bit of the Aggie Moore hymn for me. Can you do that? Can you do that? Yeah. Okay. All right. You do, of course, know that if you can prove that you know the war hymn, you cannot graduate. Okay, that is important. Okay. My role is that I'm the emulator. Okay? I tell everybody to stop because we're messed up. That's what we do. Okay? So, assistant, start counting. Running. Who's the highest priority that's ready? So you say goodbye. You're gonna. No, you're at current time. So right. So your current time just went to 2. Okay. All right. That's your current time. Well, you haven't been given an alarm by anybody. Okay, so you can't back it down. Okay. Goodbye, university. Goodbye, after you count, and now when it's time to increment up to 3. When it's time to increment up to 3, grab the running sign, drive that, okay? Up to 3. Yeah, you can erase it or right over. Okay, so get back to the colonel. Okay. Colonel, who's the highest priority? Okay. You gotta be ready. You gotta interrupt. Now you get ready for 4 seconds. Very good. Now give it. Give it down. Now, okay, pause. What is the flaw in what we have done here? We haven't made any of the other tasks ready to run yet. Okay? That's a problem. When a task isn't ready to run, it's never going to execute. In this case, it wasn't ready to run because we didn't go off and tell them, hey, you guys get to start off right away. So what I'm going to tell you now is that I'm now going to tell you we're going to reset the computer. I've now changed the code to actually initialize task 1 and task 2. So, Colonel, I'm telling you that both task 1 and task 2 are ready to run. So you give this to the highest priority. And, oh yes, it's time to get I reset you, so you need to start off with 1. No, they don't have alarms yet. They're both ready to run. They're both ready to run. So who's the highest priority that's ready to run?
That's 2x. Okay? So now what do you do? You got to tell them. So test 2, you put his alarm time as 3. He's test 2. He's test 2. That's 2. Yeah. That was it add 3 ticks or was it actually 3? Wait, no, 3 ticks, so that's actually 4. So set that as 4. Put it 4 from the current time. Right, so you're adding 3 to the current time. Okay. So now, you get now that you've done that, you head back to the kernel to running flags. Okay? Yeah. Okay. So you're gonna yeah. No, 2 ticks from her, 2 ticks from 1, right? Because he asked for 3 from 2, from 1, right? So you haven't ticked yet. Everybody's running faster than your ticks are. Okay. All right. So who's now? Right here. Two. Okay. No, on 3 you give it to you give it every time you get it back to the kernel. The kernel's in charge, but you have to tell the kernel, hey, kernel alarm went off. Okay, so now you go from up to down. Okay. She said, wait for a few ticks. Okay. So from this. Yeah, so now she's going to be 5, right? Okay. So then task 2 alarm went off. Okay. I need 3 ticks. So then task 1 alarm went off. Thank you. And then one more time around. Yeah. Oh. Yeah. Who's ready? Okay. Nobody's ready. I was ready. I was always ready. So task 1 and 2 alarm went off. Wait, 3 ticks. Okay, Paul. All right. Thank you very much, players. The idea here, for you guys to get a little idea about how task switching occurs in a kernel. And believe it or not, this is exactly what is happening, except that people are much, much smaller. Okay? That's exactly what's happening when you're doing kernel-based development. And so I wanted you guys to kind of have a taste of that. I need to remember to get my batteries fixed for the next time I teach this. I don't use these flashlights except to teach. One of them must have gotten turned on in my backpack. So the next thing that I wanted to do today is I wanted to go over the solution to the homework, which I will get published this. Probably won't get it published today just because I'm busier than a 1-hour paper hanger, but we'll get it published sometime tomorrow. Wanted to go through the homework assignment and my solution to it so that you guys can kind of see what's going on. So let me fire up Code Composer Studio. Well, no, you know what? I'm not going to fire up Code Composer Studio. I'm just going to go look at the source code directly. Okay. So I have named mine quite appropriately Blinky.
Come on. Oh, that's not the right double click. What is that opening up with? Not sure what that did, but okay. So I don't know how well you guys can see that. Let's see if I can make this a little bit bigger and still see what we need to see. I know. There we go. Let's see if that works. So, okay. All right. So, per the coding standards, I have identified this program up at the beginning of the up at its beginning, and have a basic description of what this is going to be doing. Now, how you guys solve this, because this is not technically RTOS based, it's pretty much up to you within the constraints of how I described this. But my intent, what I hope that you wrote, is something that you can use generically in other functions and certainly in other applications, and certainly that was what my intent was when I wrote what I wrote. Driver lib, this is the Code Composer Studio drivers. We do not use driver lib when developing with the RTOS, with the TI kernel. TI chose to make a different library to work with the kernel. I do not know why TI chose to use a different library to work with the kernel, but they did. And so this works great if you don't have a kernel. If you do have the kernel, then you are using a different set of functions. STDN. Who here is familiar with what the purpose of STDN is? Anybody? Has anybody ever heard of STDN? Does anybody ever include STDN in their code? Okay. So you are embedded people, and STDN, as it turns out, is really important to what you do. And so, let's see, is that? No, that's not that. What directory is that? That is, I think that's, okay. So I've made a copy of TI's STDN here for us to look at. Hello, STDN, right click, edit with Vim. Okay. So let's take a look at STDN. That is going to be, okay, we're going to have to go back to regular size for this to work. Okay. So let me show you what's in here, because this is interesting stuff. So you guys probably aren't aware, but there was a time in the early days of the C language when it was kind of the wild, wild west. Okay, the only definition for the C programming language when I first started working with C was the C programming language by Brian Kernahan and Dennis Ritchie. That was it. Which, by the way, is still the Bible, but like the Bible, it's got a lot of places that are left open to the individual's interpretation. Okay. And in the embedded world, we have to be really careful that we understand exactly what it is that we're getting into. So when the committees went about standardizing through the ANSI, the C programming language, one of the things they added to it was the ability to understand when you're writing your code exactly what your variables were in terms of the number of bits, bytes, etc. that they took in a way that when you wrote code, you could make it so it would be somewhat portable because it would conform to these standards. Now, what a lot of folks don't realize is that if you declare something to be an int in C, depending on the compiler and the target machine, you have no earthly idea how many bits that variable is. Did y'all know that? So in some cases, an int, back in the old days, there were actually some C languages that actually implemented an int as 8 bits. As a rule, ints tend to get implemented as 16 or 32 bits, but there's some instances where they're implemented as 64 bits. You don't know. And in particular, allocating something too small can be a problem. Allocating something too big takes up more space, right? Both bad things in the embedded world. So if you're writing code for me, if you're writing code to work in the embedded world, you should use stuff where you understand what it is that you're actually allocating. So stdint creates type defs for all sorts of different sized integers. So int8 underscore t, that underscore t stands for type, okay? So int8, that's an 8-bit integer. uint8, unsigned 8-bit integer. uint16, int16, int32. See how those are all defined? And those are pretty cool. So that's all, this is the basic piece. But some of the other things that, up to, in this case, up to int64. But there's some other interesting things that they have defined. So you have this type called int least 8t. And that says that I want an integer and I want it to be at least 8 bits. And they have the same thing up to 16 bits, 32 bits, 64 bits. One of the ones that's going to surprise you is that they also have this thing called fast. Okay? And the compiler manufacturer is going to implement these differently for different target machines. Okay? And the idea behind int fast8, int fast16 is I want an 8-bit integer that when the compiler writes my code to manipulate that integer, I want it to be the very fastest execution time that the compiler can accommodate. Okay? So you would think, oh, well, 8 would be an 8-bit integer, right? Not true. For an ARM-based processor, a 32-bit value, because of the way that the accumulator is built, is always faster than an 8-bit or a 16-bit manipulation. Who knew? Now, you guys don't need to be thinking about optimizing your code. But this does tell you a little bit about the way that computers work and how it can sometimes be counterintuitive about what affects the performance of a particular machine. So I wanted you guys to get to take a look at this so that you can understand a little bit about what it is that you're including. And I do want to say that if you want to write outstanding code, that you won't use int, you won't use unsigned int. You'll use int8 underscore t and 16 underscore t. You can use the fast if you want to. The only thing that I would caution you against fast, just like register variables. How many of y'all have heard of register variables? So C has the capability of tagging a variable as a register variable, which says, hey, I'm going to be accessing this a lot. Let's keep this in a local register instead of storing it out in memory. It's a leftover from when compilers weren't very smart. It's not as smart to use it anymore, but it used to be a way that you give the compiler a hint as to, I'm going to be using this variable a lot, optimize around that. Now compilers are smart enough to go in and kind of figure out your code. So let's go in, and we'll talk a little bit more here in a second about compilers optimizing your code, but let's go back to the homework assignment, which I'm sure you're all interested in. So, well, I need to just use the mouse. There we go. Okay. Well, go away. Hide. There you are. Okay. So let's go look at some more of my code. So here's my main function. First thing that I did was that I wrote a function here called int exp432 that is going to initialize all the clocks. You can see that I'm initializing the GPIO stuff. I'm initializing my timers. Then I'm getting what I'm calling timer handles and verifying that they're okay. And then this is my main loop down here. So what I'm going to show you is, I had this, what directory is that in? Can bring it up. There it is. Oh, hello. Okay. All right. I'm going to show you the flow chart for my program. And we're going to zoom in on this. So we'll go through the boring part first. All right. So that initialization program, this function right here, okay, this is what it does. It turns off the watchdog timer, it initializes the pins for the crystal, sets up the core voltages, turns on the clocks, sets up the internal clock buses, and then returns. This initialization for the timer. So let me explain how my timer stuff works. And I'll do that with this. Okay. So I have this program that I've written, this function that I've written called delaytimers.c. And in it, I've defined an initialization function, a get handle, a free handle, set timer, and is timer running. So here's the concept of what I've written.
The idea is that if I've got something that needs to be based on a timer value, what I'm going to do is that I'm going to go off, I'm going to get a handle that tells me which, so I can have multiple timers. And get this handle that says, I want this exclusively for this kind of event. And then I'm going to set it to a value. And my interrupt routine is just going to go back and it's going to decrement that value until that value gets to 0. Okay? And if I have that in an array, I can have multiple of these timers. So I can have 2, 3, 4, 5 timers all running at once. And each one is a separate counter that gets decremented. Does that make some sense? And so what I've done
is that, so like to get a, let's go over here. Let's take a look at my is timer running. So basically what happens is that when, zoom in here a little bit. Okay. Is timer running? Basically, you pass it this index into my timer stuff. And if the timer value is, the timer has not been assigned, we assume that it's not running. But if it has been running, then all we do is that we return whether or not it's active. Okay, so is the timer running? What happens when I get a timer interrupt? Well, let's set the timer first. So to set a timer, what I do is that you give me this index into that array. You tell me how many milliseconds you want to wait. And what it's going to do is that it's going to set this timer value right here to the number of milliseconds you want to wait. Okay? And then it's going to take timer active and set it to true. So once I've done that, once I've set a timer going, anytime I call is timer running, timer active is going to be true. What's going on in the background is that every time I get a sys-tick interrupt, I go through and I look at each one of my timers, this structure of timers, and I'll show you what that looks like in the here. Hold on a second here. It's play timers H. Let's look at the actual code here. I know it's going to let me bring that up. There we go. Go to the source. Okay. Oh, that's right. I didn't find that there. Bad boy. Okay. I'd find this locally here. Structures. Oh, no, that's right. I did not do this as a structure. I did this as individual arrays. So I have a timer assigned, timer active, timer value arrays. So here's what's happening. We go through. If the timer is active and the value is basically non-zero, I'm going to decrement it by the number of milliseconds that each timer tick goes in. So in this case, it's going to be timer tick is 5 milliseconds, right? So we're going to decrement it by 5 milliseconds as long as that wouldn't make it go wrap around on an overflow. Eventually, it goes to 0, and when it does go to 0, then we set timer active to false so that when we call this, the timer won't be running. So let's go back to our original code, back in Blinky. Okay. Question?
So, are we supposed to make the LED blink for a certain amount of time, or is it always
continuous? So here's what's going on. My while loop, my main while loop here, is pretty easy to follow. What we've done up here is that I have gotten my timer handle, so that's basically returning some indexes. Check to see if they're all good. If the timer is running, if the timer is no longer running, and it starts off not running, then I set the timer to be the appropriate delay. So in this, so however many milliseconds I'm delaying for the red display, I toggle. Same thing for green and the same thing for blue. Okay. All right, and so my while loop just goes through here, waits for the timer to expire, and when it does, I toggle and I reset the timer. Okay. Now, you guys may have done something different. This is one way to implement it. Everybody who can make the thing blink is going to get full credit. Is there anybody who has code that they especially are proud of that they've written that does this? No? Did everybody get the LED to blink in a pattern?
I was going to ask. I see people do it.
So that's
not at the same time.
Okay. So that was my intent, was that blink. Okay, but I will accept that blink because the fact is that it could be, you could read the documentation that way as well. So I will accept either one as perfectly valid, but that's the way that it's meant to blink. So now, what we're going to be doing is that, and that, show that blink again so that everybody can see, okay? So you're going to get this variation of colors because the greens and the green, red, and blue will be on sometimes at the same time, sometimes not. Your second homework assignment, which is available for you to download today, is to do the same thing that you just did, but with an RTOS, okay? But what I want you to do is that I want you to make it that way, okay? I don't want you to have them sequentially blinking. I want you to have them each blinking independently. Does that make sense? Everybody clear on that? Okay. All right, so let's go and take a look at, I'm going to pull up yellow. Where's the little thingy that, it's the only thing I don't like about that. Oh, there it is. About that zoom thing. If you lose it, you can't ever get it back to a reasonable size. Oh, it doesn't. Does it leave it at the normal? Well, that's cool. That makes it easier to see everything in context. That's excellent. Okay. It's weird. I would have expected it to come up like whatever I was saying, but that's okay. So what I want to do, I want to pull up, let's see, PowerPoint. I want to pull up the hints. By the way, good eye on the typos in the previous hints. Can't wait to find out what typos we've got in the new print, new help stuff. Let's see what we got here. Okay. There. Okay. Okay, so all right. They just can't make that Resource Explorer easy. That's a pain in the butt. Okay. And by the way, this is the last time that this is going to be easy to set up the new one. We'll always start off with a blank project, but what you're going to end up doing when we start using the LCD display on the Edu board, you're also going to have to create a second project that isn't this one and take the source code from that one and drop it into this one. Okay. I've been trying to figure out an easy way to make that happen, but they don't want you to have things play together. That's their thing. Okay, so I think I cut this out of source code, so it probably doesn't have typos. Pretty sure that this all compiled. Here's the way this works. There are two files. So when you create your project, two of the files that get automatically created are this MSPEXP432P401R.C and his equivalent .h file. Now, this has all of the board support package stuff. It has all the initialization things that you need to get the kernel working and to address all the IOs. Now, the reason that they do all the GPIOs and you address them with the kernel library is because it's not as big a deal with toggling IO pins that you're, just a GPIO. You could potentially use the other library. The problem is with almost every other peripheral on this device, if you're not aware, if the kernel is not aware that that pin is getting used and how it's getting used, the kernel can mess up when it does things like power management, because this particular kernel will actually put the MSP432 to sleep during when the idle task is running. Right? It's out there singing the war hymn, and it turns off the power to lots of things. Well, think about this. So let's say you're in the idle task while you're waiting for something on the I2C bus to happen. If you turn off the clock to the I2C bus, don't laugh, I've done this.
It's going to wait a long time.
Right? You're going to wait for a while. Okay? if you're waiting on something off the serial port, right, and 2 or 3 bits of it have come in, not the whole 8 bits, but 2 or 3 bits have come in, but you go to sleep, then you wake up and there's trash on the serial port because you cut off the clock. Well, this particular function takes care of making sure the kernel is aware of who's using what peripherals at what time, so the kernel knows not to turn off the RS-232 serial port. So we're going to do all of our I/O manipulating this to tell it what additional bits that we have, okay? In this particular case, we have to tell it where these LEDs are, and that's not part of the initial package. So what we're going to do is that they have this structure here called GPIO pin config, and in effect what we're doing is it's not so much a structure as it is an array, but we're going to put into it how that pin is configured. So, reading the ones that are already there. This is for the input switch. So this is saying port 1.1 is an input with a pull-up, and then it's going to generate an interrupt on a rising edge. Okay? Same thing for the pin that's connected to S2. And what we're doing is we're saying, okay, the red LED is going to be an output, and we're going to make it a standard output. It's on port 2.6. We're going to start it off with a high strength, and we're going to initialize it to be a low output to start off with. Now, this structure tells it how to initialize and where to go find these things. This enum over here basically is assigning the index into that array we just created to which pin it is. So it's very important that whatever order you declare these over here in, you declare the same ones over here in this .h file. Does that make sense? Okay. Now, once you've done that, now you can use whatever you defined as the pin name to address the pin name with the GPIO toggle. Yes. Okay. Now, there is, if you went farther down in this file, the next thing after this comma would be this MSP EXP432401 GPI pin count in that enumeration. That has to be the last one because otherwise it doesn't know how big the array is correctly. Okay. Configuration. There are 2 ways to get to, it's all controlled in this config.empty.cfg file that it creates. I don't like the fact that it's named empty. You can rename it to anything. It's just whatever .cfg file is in your source directory it's going to use as a configuration file. So you could, you could rename it my config file if you want to. This looks strangely like C, but isn't. But it has all the definitions that are used to tell the kernel how it's going to start things up. And so one of the variables is clock tick period. And if we want to do a 500 millisecond clock tick, we change it there. The other thing that we can do is that there is, Code Composer Studio has a GUI that lets you go in and edit the contents of this config file in a GUI in Code Composer. It's called xgccconf. You can also bring that up in Code Composer Studio. If you prefer working with a GUI, that's fine. I find the GUI hard to navigate. On the other hand, I find it hard to find the documentation about where these variables are. So something's going to be hard when you're doing something new if it's something I haven't told you about, okay? Either way. So those are your clues. You've got a week to get that particular task done. Also, starting, I think it's next week. Let's pull up the thing because I'm not. Somebody pull up eCampus. Real quick, pull up your eCampus because it's possible for me to have it wrong
Okay, go over to test. Test is empty, yeah.
So let's see what day I have that. Yeah, so there is your first quiz. I believe is due, I think I did that next week. Or for week following. Let's see here. Is eCampus. Yeah, see, yeah, it's basically a vocabulary test. Covered everything that you need to know about it. And let's see when it gets activated. Okay. So noon today, it pops up. And the due date is February the 2nd, I believe. Is that right? Yeah, February 2nd. Yeah. So it does pop up today, lunchtime. So you guys are sometime get a hold of that. It's a vocabulary quiz. It is a one-time through. I haven't set it up so that you can redo it. I want you to go through and get it all done. If you study the slides from week 1 and week 2, or re-listen to the lectures, or do both, you'll ace the test. Okay, it's no big deal. I want to thank all of you who have contributed to the discussion board, and also let you know that I am keeping track of it, and that you all will get 5 extra points on this first homework assignment when I grade them. So that's cool. Any other questions that you guys have got? So Monday, we're going to be talking about semaphores. One thing I want you guys to keep in mind, since we're in here where we've got laptops and stuff, if you've got very specific questions about Wednesdays, I'd like this to be as interactive as possible. So if you guys have specific questions that you'd like to ask, either about the homework or about something else that you're doing that's associated with kernels, then if you could let me know by, say, noon on Tuesday so that I can kind of be prepared with something to pull up, we can do some interactive development here, okay? And actually, as we get in, we will do more interactive development even on your homework assignments as we get deeper into the class, things get a lot more complex. Right now, it should be pretty straightforward. It's mostly plug it in, follow the instructions, right? Cool. Well, that's all I got for today, guys. Thank you. And this is a better space than 105.